Welcome to this edition of Ask the Experts. Today I have, actually for the second time, our CTO, Carl Moberg. Welcome.
Thank you.
It's good to have you again.
Appreciate it. Thank you very much.
This will be, it's usually pretty technical. This will be a deep dive into technical things. It will be really, really interesting. I'm really excited for this. If you have any questions, please post them in the chat. Given the amount of ground that we're going to cover today, we will save the questions for the end of the session. But yeah, any type of question, just post them in the chat and we'll try to cover them at the end of the session. So as you can see, we have quite a lot of ground to cover in today's session. So I'm just going to hand it over to you, Carl. Again, thanks for being here.
Thank you, Frederick. And yeah, so the theme of this presentation, or the theme of this Ask the Expert session, is actually me reflecting a little bit over a project that I've done over the last couple of weeks. It's a project where I have taken a recurring theme in user conversations and tried to build it myself. And the recurring theme here is that there's a lot of our users, several of our user teams, or teams that use our product, that are on a path to explore how to deploy pretty straightforward inference applications through our platform. And as I did this, and I picked a particular case, I picked a person counter or a visitor counter, which is also kind of a recurring, pretty simple application, and actually a type of application that we have used in our demos before, but we haven't really used a real life version with an actual camera. We have used more of a mocked up version. As I started to build this on actual real hardware with actual real monitoring and actual real configuration around it, I came across a couple of things that were general enough in nature that I thought it'd be interesting to actually capture. So both in this Ask the Expert session here today, but also as a blog post, and I'm also going to post some example code or the resulting code that we will look through on a public Git repo. So what I've actually did was that I actually went ahead and ordered some hardware. So I was going to start by actually showing that. And actually, let me just tell you also that looking at the agenda, I'll talk a little bit about the actual use case. I'll talk a little bit about the actual nature of the application itself. I'll talk about how to package the application for deployment, and that's where some of the more interesting, I think, learnings came about, because most of the tutorials and demos that you'll find around these types of applications doesn't take into account, of course, preparing the application for headless deployment at scale, including monitoring and health tracking and stuff like that. So that's going to be a good one. We're going to look at the application and deployment specifications that I ended up with for the Avasa platform. And we're going to talk a little bit about what some good approaches to monitoring this type of application. And then, hopefully on time, we'll do some conclusions and hopefully some interesting questions from you guys in the audience. So I thought I'd start with looking at what I've built on. And what I did was, I guess, the starting point for many kind of scaled down projects like this is that I started with buying some Raspberry Pi hardware. So I have an Avasa control tower set up here with a couple of sites. The one we're going to focus on today is the Avasa Stockholm office. It's literally a camera and a Raspberry setup in this room, and we'll demo it towards the end. So if nothing else, stay for the camera-based demo. And if I open the Stockholm office here, you'll see that it's a single host, and it's actually a Raspberry Pi running Debian Linux. It's obviously an ARM64 platform. I'm using Docker here. So pretty bog standard. So it's a Raspberry 5. It actually has got what they call an AI Hat Plus, which is an accelerator from a company called Halo. That's the actual hardware in that. And obviously, I've attached a camera as well, and we'll look at what that means. But just to give you a sense here, I've installed basic Debian on this, actually the bookworm version. I'm actually using Docker, and this is my kind of base platform for starting this journey here.
Can I ask real quick? So I know we're going to look at the container file and all that. Do you have to install anything on the host except from Docker and the Edge Enforcer and all that?
No. Nope. So it was very, very straightforward. Actually, our friends over at Raspberry has made this really easy, actually. So there was a couple of tricky things with which version of the actually Raspberry Pi OS to pick to match the drivers for some of the hardware, because of course they track Debian pretty closely. So I stuck with Bookworm instead of Trixie, which is actually a more recent version, just to make sure that I had the right drivers. Otherwise, very, very straightforward.
Cool.
The tricky parts actually come in the container file. That's where things get a little more interesting. All right, so I'm going to use, pretty well-known tools here. I did most of my work in VS Code this time. So that's where we're going to inspect files, and we'll look at some shell environments, and then obviously back to the web UI. So here's my resulting container file. Pretty standard. I think there's a couple of things that are interesting to point out. One is that I wanted a slim version of the base image. So actually Raspberry doesn't actually provide, as far as I could find it, their own base containers, right? So there's no Raspberry Pi OS base container. So you have to pick something else. Which makes life a little interesting because what that drives is that, on the other hand, in order to get support for the Raspberry Pi camera and for the AI Hat Plus, there's a couple of tools that we need to actually fish out of the Raspberry Pi registries. So we actually had to kind of set that up here to make that registry available or repo available. So first of all, installing just very basic things required by the whole setup, and then actually making sure that we reach Raspberry's own registries. Because this whole thing, as accessible as it is usually addressed or usually kind of built upon these libraries here. So in order to get access to the camera at the base layer, there's something called libcamera, and then we use a Python binding for the Raspberry version of this camera called PyCamera 2. So this I had to install just to get the actual driver and the Python library for accessing the camera. And then things became even more interesting. So down here, of course, we needed both a driver layer and a Python binding for the actual accelerator, for the Halo accelerator. And that's actually not publicly available. So I had to create a developer account to get access to that. So I kind of hand install, first of all, a driver for Debian, for ARM64, for the Halo chipset or for the Halo controller. And then I have to match that with the right Python wheel. And a snag here was that there is literally then, of course, a connection between which driver version I'm using and the right version of the Python library, also tied to which version of Python. So there's like a three-way thing here between the Python I picked and which version of the driver I have running on the box. So a little bit of trial and error here to get all this running and actually set up inside of the container. Apart from that, pretty straightforward. May actually be worth pointing out that you want to manage, generally speaking, the model files as a separate copy statement, because over time, I clearly see that with some of our users, this is actually the layer that changes much faster than others. And in order to get to kind of a diff or delta-based updates, it's really useful to do it like this, so you get that as a separate blob.
But that model is something you downloaded. It's not something you have trained for this particular. It's actually an off-the-shelf model?
Yes, excellent question. So what I'm going to show here, maybe I didn't spend too much time on that, is I've built an application that tracks persons in the field of view for the camera and counts them passing a virtual line. And there's eminent support for that in widely used models. The one that seems dominant right now is this one. It's actually called YOLO version 11. Does object identification, the object classification, object tracking. So literally everything I needed in a single well-used, well-understood model file. And it's in HEF format, which is actually specific to the Halo chipset. So it's not ONNX or any of the other kind of more broadly used. It's very specific for this chip or for this neural net accelerator. So a little bit of work to get that converted. I know there are places to find it as well, but it's specific to the platform. And I'm not going to go through the code to any extent, but there's a couple of things that I did in the actual application code that I think is kind of appropriate because it's appropriate to talk about because it's kind of connected to how this application will work at the edge. One of the more important things in my mind is actually to be able to instrument or take care of instrumenting the log level through environment variables. It turns out, as I did a couple of things over and over again, it was very handy to be able to increase or decrease the log level while the application was running at the edge, which is a small thing that's maybe isn't very obvious if you do most of your development locally. But if you have a target platform other than your laptop, and that target platform is remote and it's headless, then actually having the ability to increase or decrease the log level is very, very useful. And another thing that I actually put in code is this is a web application. And of course, in order to provide some stable means of probing this application for actual readiness, and we'll look at this later, I added a route here in the web app called HealthZ that I can later use then in probes to make sure that in this case I'm checking that the network is up and that the camera is ready, so I can find out if that doesn't work through a simple probe.
When you say network there, it's not the network, it's the neural.
Right, exactly.
Yeah.
Without going into too much details, of course, you shoot the HEF file, the model into the neural net, and you get a virtual input port where you send in my case, images, and you get a virtual output port where you get a tensor that gives you the kind of response you need. In my case, it's bounding boxes and classic or tracker IDs and things like that. So that network needs to be up and running and ready for the application to actually work. And that may take a couple of seconds when the application starts. And of course, I mean, wrapping up maybe this first step here, what I struggle with, or what was interesting, is to think through what kind of base container to use and what's the right set of drivers and libraries then to support my use case. And it can be pretty tricky because most of the actual examples and tutorials that I saw using these exact things had them natively installed on a Raspberry that actually had a keyboard and usually actually even a monitor connected to it. And of course, we're not running on Raspberry. In this case, we're running inside of a container, and we certainly don't have a keyboard, nor do we have a monitor. So have to take that into account as we go through this. And the second thing, even though it wasn't very advanced in this case, really thinking through how to manage the lifecycle of the model, make sure that it's in a separate copy statement. Actually, for some of our users, I also notice a pattern where they put the version of the model as part of the application version or application name even, so you can track that over time. But with all this in place, it works. And so the next step for me was to look at how do we actually package the application for deployment. And the first thing here to note, of course, is that with the drivers in place and the libraries in place, this assumes that we have access to the actual device node, so the physical representation or the device node representations of the physical network, the Halo chip, and the camera, of course. And the way that works in Linux, of course, is through udev. So one of the earliest things I had to do was to look at this site here, this host, and make sure that I made available to the container a couple of subsystems here. This took a little bit of experimenting as well. Actually, we have kind of a couple of really handy features, and I'll show you that in a moment here, but to inspect UDEV and look at what kind of subsystems to use. So I made use of our device labels. And so this matches on UDEV subsystems. And turns out that I needed two types or two labels here. One was what's called a Halo character device. This is literally how Halo is actually, or the Halo chip is, well, manifests itself through a driver. So I had to give this, provide access to this for the driver to be able to load the HEF file into the chip. And the second thing, it turned out I needed three subsystems for the camera, media, video for Linux, and then DMA heap. So by doing this in the site configuration, obviously, we detect the Halo stuff and the media stuff. And when the device labels are created like this, we get access to them from the application. So we can ask through the application specification to get these things and the corresponding device nodes mounted into the application or into the container itself. And the way it looks, of course, here is that we can see all the actual devices or the device nodes that are matched, which is quite a bit. I don't know that my application uses all of these, but it definitely uses a subset to get access to the camera and to the Halo device.
So we have documentation on how to do that, but it still takes some trial and error, right? You got to figure out what devices you need.
Exactly. Yeah. So both to discover what the devices are, let me briefly show you. So we can always go to host UDEV here, unselect all, and then look at these, right? So these are all the subsystems. And so Halo character device looks like that. And then media and the camera is further down here, like video for Linux. So it took a little bit of poking around here, actually, to find the right drivers and the right device nodes and make them available through labels so that the applications can use them. All right, so with that in place, we can now do the magic incantation here and actually build this and push it. So what I do is that I build an image from that container file and I push it straight into the control tower to make it available for an application specification. So this is in preparation. So I've done some preparatory work here, so this is fast. Another aspect, a small observation that I made was that even small applications like I perceive this to be actually becomes quite big. So the default size of even a container like this is about a gig. That's not really a viable size for something that's deployed to the edge, shouldn't be that big. So, but the next step would be to be a little more precise in the exact requirements. So we will have to live with this somewhat large container image at this point.
So maybe in a follow-up post.
Yeah,
where you can slim that down.
Deeper dive. Yeah. All right, so now the image is available in the control tower, so we can always inspect that through the registry, and we can see that I have my people counter image here, which is, of course, a good setup to actually start creating or start putting in my application specification. So let's briefly look at that one as well. A couple of things that are specific here. I think the number one thing that took me a little time is actually that we need a system, what's called a system volume. The application or any driver that has to do with these types of device nodes needs access to a volume that's actually well, system-wide. It's under /run/udev. So what we had to do in this system was to go to the system level here and declare system volumes. This means that in any location where we ask for run udev, we will give that container access to /run/udev, which is kind of a ephemeral state set of directories for drivers to find the actual device nodes between short-term names or short names like video 0 and other things like that. So had to make that available. And another thing that we had to do is kind of down here, which is we had to turn on user namespace. That could be its own presentation on what that means. But let's just say that when using Docker, this is a key setup or key configuration in order to make the namespace mapping between the container, the environment and the host environment work the way the code expects. I also wanted to enable log level modifications on a site level. So instead of turning up the log level in all deployments, I wanted to do it per site. So I use our site labels here, and you can see that I'm using a label called people counter log level that I've also actually declared on the site here. So you can see that I've set it up to default to info. So if I wanted to turn it up for instances running on this site, I will change that label and it will restart or update the application with the updated log level.
Very cool.
I declared a probe to the health C route that I showed you before. I declared an ingress IP, and I wanted to expose 8080 because that's where my web application is. Apart from that, it's actually pretty straightforward. So what I'm going to do now is I'm going to grab this application specification, and I will put it in as a new application. So submit that. And since the corresponding container image is already available, it will actually be ready for deployment right away. So now we're actually ready to deploy this. And I'm going to do that. And we've declared it to be version 1. Let's add a deployment specification. Let's call it people counter deployment. Pick the right application, pick my only version, match on my little site here. Stockholm office. It's a single site, so no tricky things, and then wait for this to start. Takes a couple of seconds to get the image into the local site, and we'll wait for it to start up. We can prepare by watching the images get loaded. And we can see that it's actually already started measuring.
There you go.
Yeah.
So now it's probing, right?
Now it's probing.
Yep.
According to the probe that we put up. Okay. So we actually have a problem. It almost feels like a setup, Fredrik, that we have a problem here.
It does. But this is actually a somewhat common theme. We've seen this happen when people test our stuff. They do everything right, but they miss a tiny part.
Tiny part.
Yeah.
So I'm going to use logs here then to look at what actually happened. And what I can see here is that let me stop the query. My camera driver actually seems to be unable to reach the actual camera device node. And that's because I made a deliberate mistake that I'll show you guys here, in that I never asked to actually mount the drivers into the container. And without, of course, access to the device nodes, the library will never reach either the neural net or the actual camera itself. So let me correct the mistake and pick up the actual right application specification here. So the difference is up here. So now we're actually asking for mounts, the actual devices. So we're going to fix that, and we're going to declare a new version here, version 002, prepare to upgrade.
So you need to declare the labels on the site, but you also need to tell us, the system, that you actually want to access those devices in your application.
Exactly. So now I'm prepared to roll out the new correct version. So I'll do that by pointing to 002, keep the same label matching, and update. And we'll go back and wait for this to get updated. So this was also a very kind of interesting and important part of the whole process of putting this together, was iterating, like trying things out, because again, this is remote access, so I couldn't really go into the host. I didn't have a screen or a keyboard. So being able to do this and update the version over and over again was a really, really important thing. So now we're up and running and things are actually working. It actually is going. I can look at the logs again to make sure that it's actually doing something. And now it looks way better. It's responding well to the health Z probes, and it's not complaining about camera access at all.
Very nice.
So I guess we're working towards the kind of the big moment here, Fredrik.
I know.
Is to actually look at I'm conveniently on the actual Ingress network, so I can easily just open up. I can look at the application like this and look at what the IP address is for the Ingress IP and go there up here. And here we go. Here is the actual application, web application running with a camera and an accelerator. It's identifying a Christmas tree as a potted plant and a ball as a sports ball, and it's struggling with a little Santa down there. But maybe if we had someone walk past it, that'd be cool. Yeah, let's do it. There you go, tracking you. And the left to right counter bumped. Let's try the right to left. It is working. Really cool. Keep going, keep going, because I want to show the audience the following too. I'm going to show them some logs here. Keep walking, and now we can see the actual crossing also in the logs for the application. All right, and we can leave it here. Now you're done, Fredrik. Thank you very much for being a counted person. Okay, I think that kind of wraps up the main part of the presentation. I guess the conclusion from my side here is that putting this project together took maybe a little more time than I thought, and the majority of the extra time was actually parrying for the fact that this is remote deployments, again, headless environments. So getting the code right while iterating on remote installations was a big thing. I think it's a decent reflection actually of where we see the edge AI industry is at the moment. So the components are here. We see the market they're trying to build the experience, but some of the kind of operational parts are less well understood and things that needs to be kind of worked through. And while, of course, this was more of a local itch to scratch, I found it really interesting that some of the things that I stumbled over are things that actually come up in real life conversations with customers. So hopefully this kind of session and the write-up that we are going to publish here and the code can help people kind of jumps through some of the hoops that can otherwise be a little bit of a hold-up.
Yeah, really cool. Thank you.
Oh, you're welcome. Do we have any questions?
We do.
Awesome.
We do. So let's start with the first one here. So the question is, why not use an OAK-D camera? It performs all the work, object detection or tracking, and sends the information to the Raspberry in real time with no noticeable latency over the USB interface. I think that's a good question.
It is a great question. And I think it cuts deep, right? Because some of our customers are more like, let's buy purpose-built systems for specific things, maybe like really basics things like a people counter. And there's obviously off-the-shelf products for that from some of the major vendors that will send results. What we do see is that there's a lot of users that want to pick data from this sensor and combine it in a more raw fashion with other things. I can't come up with something specific just for a people counter, but certainly you can think of multi-sensor or multimodal sensors then coming together and actually have that data in the type of code that you yourself control to get a more, let's call it, experimental version. But if they realize that the only thing we're doing is what this product can do, those kinds of problems are already solved. So this is more towards more the agile and experience-based environments. But it's a good question.
Yeah, and I would say some of our customers also have cameras in place already that they want to use, and be that like wired cameras or IP cameras. But Yeah, a lot of them already have cameras in place.
Yeah.
So here's another question. What is important to keep in mind when it comes to deploying a model versus deploying an app?
I think the big one for me is the realization that for many of the use cases I see, there's usually three components, and it's kind of the same that I have in this application. There's the inference engine that usually never changes or rarely changes, unless the vendor or the open source project updates. There's the kind of front end code, in my case, a very simple Flask Python application. That doesn't change very often either, but there's a lot of movement in the model file itself. So actually making sure that you package the application such that, first of all, you have an efficient distribution. And one of the little tricks that I showed here was to keep it in its own layer. So whenever if the only thing I change in the container file is the actual pointer to the copy statement, then that's the only thing that will be passed during container pulls. And trickling that up into the actual versioning, so you actually understand what are the exact version of the application, or sorry, the model that I'm using, are two things that stuck out to me during this exercise.
So we're almost out of time. We have two questions that I haven't covered. We tried to cover them shortly.
Sure.
So first of the last two, why using Docker and not Aptainer?
Ooh, I don't even know what Aptainer is. My choice was between Docker and Podman. And so Raspberry Pi comes with Docker.
Yeah.
I have to read up on Aptainer.
Yeah.
Good one. Good
Okay.
one. Haven't heard about it. Yeah.
Sorry, that's the best we can.
Yeah.
What communication protocol is used between the server and the Raspberry Pi?
Yeah, so that's a big question as well. So our little agent that actually does the scheduling of the host calls home over MTLS or QUIC. So it depends on the networking between them. I think we default to QUIC these days. And then we keep that alive, which gives us a very nice bidirectional channel-based programming model. So for some of the things that we showed here, like picking up the host metrics, happens over that channel. And the same thing goes with pulling the container images. Of course, is initiated from the edge towards the control tower registry. So it goes over our call home protocol, which is MTLS or QUIC, so TCP or UDP.
Thank you. So thanks again, Carl, for joining us and doing all this work and explaining it in such a good detail. Thanks for everybody listening, and thanks for questions. We will be back after New Year's with a new topic. So hopefully I'll see you then.